Good morning.
Good morning, sir.
Now I'll just put we have started. We have started. So welcome all of you. So today is the day 3, session 2, and Mr. Vineet Bansal will be continuing with the Labview, Labview that assignments and everything.
Shall I start, sir?
I'll make you co-host.
Sure, sir. Okay, so good morning, everyone. Thanks for joining us. I hope my audio is clear and you're able to view my slides.
Presently, that series slides are coming, Vineet.
Okay, let me try again, sir. Is my screen visible now, or is it still the
agenda is visible now? Extending evaluation, calculator application, like that.
Great. I'll switch it to November. Okay, great. Now, I think, yes, one topic we had missed yesterday, or rather a couple of topics we missed yesterday, which we could not cover due to lack of time, but I have included those in today's agenda. So I would want to start with helping you extend your evaluation for Labview. Labview has a certain learning curve, and it will take you some time to learn this. So it's good to have it extended till 45 days. Then we'll get into the homework question, which was the calculator application. We had yesterday interfaced Arduino, so we'll have a quick comparison of Arduino and data acquisition system. We'll interface with data acquisition system. We'll simulate a DAC device on all of our computers and acquire signal from that. And then we will acquire sound, play with the acquired audio. We'll change the frequency, pass it through various filters, etc. Then maybe in the next session, which is post-lunch, we'll get into the machine vision part. So we will look into various sorts of cameras, various interface buses, and how we can acquire from camera. Then we'll get into some of the algorithms such as geometric matching and 2D barcode reading. And if time permits, we'll touch upon control systems as well. Does this sound okay to everyone?
Yes, sir.
Great. So with that, I'll jump on to extending your evaluation. How do you extend your evaluation? So you can simply go to Start menu, type License Manager. You can see this tool, NI License Manager. You can open this tool. It would have got installed along with your software while you have installed software. So this is one-stop shop for all the softwares which are installed on your system, basically licensing of all the softwares which are installed on your system. Right? Licensing in Labview happens based on computer ID. So if I click on computer information, it gives me computer ID. This computer ID is nothing but it's an encrypted number which is generated based on the MAC ID of your computer. So we do a specific encryption on your MAC ID and create this number. In certain cases where network port may not be available, MAC ID may not be there on the system, we take up the hard disk serial number. Yeah? And from there we encrypt and create this computer ID. Okay, so all your licenses are attached to a computer ID. Right now, if you look at, I am also using Labview in evaluation mode on this computer. My development system is right now having 44 days remaining. I extended yesterday. For you, it will be showing 3 or 4 days remaining. Yeah. Yellow color means it is in evaluation. Green color means it is licensed. And if it is having no color, then there is no license associated with that on your system. Right? So one particular software, which is Vision Development Module, is having only 6 days remaining license on my computer. So I will extend it in front of you. You can do it along with me. You can go to Activate Software. Okay. Now, while you activate software, it basically asks you to check license check your account for licenses. If you have bought any license from NI, it will be attached to your ni.com account. So it will find licenses from there and activate. We don't have that right now. You can enter a serial number if you have got from NI. If you have bought a license from NI will also give you a serial number. You can put here and activate using that. You can enter activation codes, like it will be a 20-character code. Let's say you're working on a project, you've placed an order with NI for the software, but the software has not yet been delivered by NI, but you want to get started. So NI can issue a 20-character key code through which your software will be activated for a certain period of time. Right? Now, you can also have a volume license server. We have an offering for academic institutions to have an academic site license. What do I mean by academic site license? It is a full bundle of Labview. When I say full bundle of Labview, I mean it will include Labview, Labview Real-Time, Labview FPGA, signal processing, advanced signal processing, and various other 20-25 different tools which can be used for academic research as well as teaching. That is 98% discounted to the market price of Labview. So it's very heavily discounted for institutions and organizations. If you have that, then you can connect your system to the server and have a volume license, such as academic site license. We don't have all of this today in the workshop, so we will simply click on Extend Trial. So it tells me that my Vision Development Module has been extended to 44 days now. In your case, it might ask you to log on to ni.com. While all of you would have downloaded certain drivers from ni.com, you would have created your ni.com profile, right? So if you extend it, will
Hello?
Any queries? Yes, sir.
Sir, Raghav.
Yes.
Raghav. Sir, sir, we at least I didn't have to create any NI profile while downloading the 2 drivers from ni.com. It was direct download was available, so I didn't have to create any profile over there. So right now to extend this, I have to create an account with NI.
Is it asking you to create an account, Raghav? Like while you
get it's saying that loading with user account utility, please log in to continue, and there is a window saying NI user account, login or create account.
Yeah, you can simply create an account, Raghav. It will be free of cost account. You will not be charged anything for that. So you can put in your credentials and just create your account.
Okay, and then after that, I can extend my trial over here just like you showed.
Yes. After that, you can simply come here and extend your trial. You can try that during lunchtime. And if any one of you, whoever is on the call, face any trouble in extending, please feel free to bring it just after lunch in the next session. I will want to help you out. I would want to help you out to get it extended. Yeah. Another thing I will add here is there is a community edition of Labview which NI has launched this year for the first time. That community edition is Labview. It's a open source Labview which you can use on your system. You will not be charged for it, but it should only be used for personal learning. It should not be used for publishing research papers, publishing research, or academic teaching. Right? That should only be for your personal learning. So you can go to ni.com and download the community edition that will have a Labview professional development system. So the tools which we have used till yesterday or maybe till today, till Talking Tom application, all those tools will be available in Labview Community Edition as well. In fact, the links library, which we discussed, Labview Interface Library, Arduino Interface Library, that will also be available in Community Edition, free of cost. Machine vision toolkits, signal processing toolkits, which we will use today, may not be available in the Community Edition. Right?
Sir?
Yes. Yes, Raghav.
What is the validity of that community edition?
Community edition is free, so you can use it for however long you want to use it.
Okay, sir.
Right? Yes.
I have searched for the community edition on the NI website. There are two options like Labview 2020 community edition and Nxg community edition. So which one should we use, or what's the difference between the two?
So Labview Nxg is a next generation Labview being developed by NI. The full suite is not yet rolled out. The full suite will be rolled out by probably next year.
Okay.
So what's the difference between Labview and Labview Nxg? The current version of Labview, which we have been using for last 3 or 4 days in the workshop, is basically the Labview which is being developed upon for last 40 years, or rather last 32 years, right? So Labview was launched first 32 years back, which had, the similar user interface which we are using today. It started 32 years back. Over 32 years, we've been building on top of the first version of Labview. A few years back, we understood that there are certain shortcomings of this approach. Certain shortcomings like zoom in, zoom out feature is not there, right? If I want to zoom in into the block diagram, I cannot zoom in into my block diagram on the normal Labview. Then another thing was we wanted to match the pace of industry for Internet of Things applications. So we wanted to have things like web DIs, wherein you can simply export your Labview program to an HTML code that can run on a server or that can be hosted as a website for you to interface with your machines through Internet. Right? So there are various new features related to Internet of Things, related to cloud connectivity, related to deep learning available in NXG. But right now, NXG's full suite is not out, so we have not been actively training that right now. But once it is fully out by next year or early next year, we will be conducting workshops, trainings, and classroom programs for that as well. Did I answer your question, Radhav?
Yes, sir. So right now it's better to go with 2020 because it's a complete package, like kind of a complete package. NXG is still under development.
Yes, you are right, Raghav. But since you are students, or rather just fresh graduates maybe, or you may be PhD scholars, you can also try your hands on NXG. No harm in that. It's a pretty good tool for Internet of Things kind of applications. So what I will do is I will post out a link maybe in the afternoon for a webinar on web VIs. Okay. We are working on VIs on our computer right now, but how you can host it as an HTML page and make a website out of it. There is a detailed 1-hour webinar from NI on web VI. I will pass it on the link during the next session. Right? You can view that and you can start using NXT also at a later point in time if you want to try your hands on it. For now, download Labview 2020 Community Edition and use that. Okay.
Thank you, sir.
Thank you, Raghav, for asking. Now, with that, I'll jump on to the next agenda point in my list, which is the calculator application. So quickly on the chat window, please help me understand how many of you have tried it, how many of you were successful in building an application, and how many of you faced challenges. So please share the responses on the chat window. Partially successful. Okay. I am not receiving response from everybody. Should I create a poll for this? I actually want to hear from everyone so that I can decide the pace at which I go for the building calculator application. Can I have response from everyone on the chat window? Partially face problem while handling divide by zero case. Okay. Okay. Fine. I think then let's build an application, and I will stress upon divide by zero case. Raghav, you have also mentioned partially successful. Could you share the problem you had faced? Kalpana ma'am, you as well.
Sir, the problem I faced was divide by 0 only. Actually, what I could do is I could indicate that I am doing a divide by 0 thing.
Okay. Okay.
I'm doing a divide by 0 operation, so that will be an error. I can indicate using an LED light
Okay.
from the Boolean palette. But
Okay.
I'm not. But I tried to stop that functionality. Like if denominator is 0, then the result will be no result will be given, and there should be a string indicator saying that error in words. I tried that, so that string indicator was 0 success, and for no results, sir, what I did was I compared it with a not equal to, then converted it from Boolean to 0 or 1. Then
Okay.
I gave the division result. Like
Okay.
if it is not equal to 0, then only division will happen. Otherwise, it won't.
Understood. Understood.
Okay. And that I was trying. So the result was ANDed with the Boolean to 0 to 1 result. So if it is not equal, then it will give me 1. And the result was ANDed with 1, and it will give me the output. But there, the problem is that it won't work for decimal numbers. Floating point numbers won't work over there because floating points will be converted.
Understood. Okay, no problem. I think let's relook at this problem. We'll quickly create a calculator. If you have your program open, you can make corrections while I create one. I'll go slightly faster on this because we want to cover a lot of things today. So to create a calculator, first of all, we need to have 2 inputs from the user, or rather 3 inputs from the user. 2 are the numbers, and third is the operator, what operator he wants to perform, or what operation he wants to perform on these numbers. So we go to front panel, create controls. Controls are where a user can enter values. So I go to silver, create numeric, and say this as A. Okay. I again go to numeric, create another number, call it B. Now, what representation both of them are in right now?
Floating point.
They are both are floating point double precision numbers. So I can enter decimal values here as well. Yeah, because it's a floating point number. Yeah. Now I will add one indicator to indicate the result. Yeah. And we need to add a control to provide operation, like what operation user wants to perform on these 2 numbers. Now, how many of you understand the term called enumerations? Parikshit sir had covered this on the first day. How many of you understand enum? Okay. Basically, what enumeration does is, so where to find enumeration, first of all, I'll do that again for you. Right click on the front panel, you go to controls palette. Under controls palette, go to silver. Under silver, go to ring and enum and choose enumeration. Okay. Now, what enumeration does is basically it links various strings to a particular decimal number. So let's say it will map add to 0, subtract to 1, multiplication to 2, division to, let's say, 3. That means if a user choose add here, if I add a string here add, if a user choose that, it will go as 0 to my block diagram. I can handle it as a number instead of string, right? So let's try that. I go here and click on edit items. Okay. And I insert my first value, which is, let's say, add. I insert the second value, which is, let's say, subtract. I insert another value, let's say, which is multiplication. And I insert another value, which is division. Is everyone with me till this point, or? Sure, I'll do that. So let me do that again for you. I'll remove this. We will go to silver, and we'll go to ring and enum, and place an enum.
Vineet,
Yes, sir.
we have to enter in the reverse manner, na? Because it goes one down.
Yeah, I will do that, sir. I'll help them change that. But first of all, let's enter the values. Okay, everyone done till this point where you have been able to place an enumeration on the front panel? Okay, I assume that as yes, that you have been able to place an enumeration. I will right click this enumeration and I would say edit items. Under the edit items, I can insert, add, subtract, multiply, and insert, divide. Okay. Done till this point. If anyone has not been able to reach to this point, please feel free to unmute and let me know. Am I audible? Parikshit sir, am I audible? Or
Yes.
Okay.
Yes, I'm getting.
Okay. Okay. Participants, I know it's a Sunday afternoon, just around the corner of the afternoon, but please be slightly active. Have you been able to reach till this point? Okay, I take that as yes. Then I'll move ahead. Now divide is right now assigned a value 0, multiply is assigned a value 1, subtract is assigned a value 2, and add is assigned a value 3. I can move add up to make it 0, and I can move subtract up to make it 1. I can move multiply up to make it 2. So we have add, subtract, multiply, divide assigned values as 0, 1, 2, 3. Okay. Now, once this is done, my front panel is more or less done. I can add certain text here. How do I add a text here? I can simply double click on my screen and it will start typing and we can start typing here. I can of course change the size and text of this and I can make it bold by pressing Ctrl+B. Okay, I can also change the background of the screen. Go to the bottom corner where two scroll bars meet. At this point, right click and say properties, go to background and make it metal brushed. Okay, my front panel is done now. I will move back to my block diagram. As you can see that while I placed certain controls on the front panels, I have their terminals on the block diagram. Now I will place a structure which is a case structure, right, to handle various cases of add, subtract, multiply, divide. So I go to the block diagram, right click and go to functions palette. Under functions palette, go to programming. Under programming, go to structures. Under structures, go to case structure. Okay, my case selector terminal would be this enum. As soon as I connect it, though it is an integer, blue numbers are represented by integers. Though it is an integer, but on the case structure, you can see them as strings. Why? Because enumeration has already mapped these strings to decimal numbers, right? Now I only have two cases here, add and subtract. I want to add two more cases. So I can right click the case structure and say add case for every value. As soon as I do that, I will have 4 cases, one for add, subtract, multiply, divide each. Yeah. I will wire my A terminal or the terminal of my A control to the boundary of the case structure to create an input tunnel. Similar way, I will wire terminal of B to the boundary of my case structure to make an input terminal B, right? I'll go to the add case. I will simply right click, go to functions palette. In the functions palette, under the programming tab, I'll go to numeric. Under numeric, I have add operation, I have subtract operation, I have multiply operation, and I have divide operation. Yeah, I will close this here. I've placed add operation inside the add case, and I am just wiring the numbers. The output has been wired from the add operator to the result. While I was wiring, it automatically created an output tunnel. Right? It is right now blank in color, or there's a small white patch inside this tunnel. Can anybody answer as to why?
Because all cases are not defined right now.
Yes, all cases are not yet defined. That's a very right answer. So let's define it for the other cases. I'll go to subtract, so you can see nothing is going here. So if this program runs, Labview would not know what to send here, what to show in the result, and hence it gives us an error that you have not wired the tunnel. So I will place subtract inside the subtract loop, go here, connect it, and connect the result. I will again go back to multiply. In the multiply, again I will move my multiply operator inside the loop, wire these, and connect it to result. In the divide operation, this is the critical piece. For the divide operation, what we can do is, if I simply wire this, and if this is 0, it will pass on NaN result. Okay, it will pass on not a number. Yeah. So what we can do is, we can create another case structure inside this, okay, which will be around this portion of my code. The selector terminal of this case would basically be connected to a logic. So I want to create some space here because I'm left with little space. So what I do is, I press Control on my keyboard, click here, left click here, and drag my mouse. So I'm able to create some space for myself to add some logic here. Now the logic I want to add is whether it is equal to 0. If B is equal to 0, then the division should not happen, right? So rather I should say B is not equal to 0. If B is not equal to 0, and if that statement is true, then division will happen. If B is equal to 0, then this will go to false case, and we can add our logic here. So what we will do, we will go to comparison terminal under programming. We go to comparison, and we say if it is not equal to 0. Yeah. If number is not equal to 0, then it will give us a true. Okay. So let's say number is not equal to 0, it gives a true. I wire this here. It will go into the true case, which is division by, which is a division operation. Now, if let's say the number is equal to 0, then this operator will give a false result or a true result. It will give a false result, right? So we get to false, and in the false operation, we can pass on a 0 to it if we want, or it can still pass on infinity or not a number. Raghav mentioned it shows infinity at your end. I might be wrong. It might show infinity instead of NaN. So we can either simply let it divide and show infinity in the results, but we will pass on a message to user here, right? How do we pass a message to user? We can create a string indicator. How do we do that? We again come to front panel, right click on the front panel, go to silver, string, and create a string indicator. Okay, now we have error here. Okay, we have error.
Hello, sir.
Yes, ma'am.
So can you repeat division section again?
Sure, absolutely, ma'am. So, do you want me to repeat the internal, the inside case structure as well, ma'am?
Yes, sir.
Okay, no problem. I will delete this. So now we've just finished the add, subtract, multiply, and we are doing our programming again for the divide portion. So what we need to do is, first of all, we need to check whether this number is equal to 0 or not. Yeah. So to find that whether this number is equal to 0 or not, I can simply use a comparison operator. How do I find the comparison operator? I right click on the block diagram, go under the programming tab, go to comparison, and say not equal to 0. Okay. Now if I'm using a not equal to 0 operator, that means if a number is equal to 0, it will give me false. If a number is not equal to 0, it will give me true. So if it is not equal to 0, then I will get true. If it is equal to 0, then I get false. Yeah, I've just added this as a comment for you to remember this. How to add a comment? You can simply double click and start writing. Yeah. Is this clear till this point? Should we move ahead? I cannot hear anyone. I'll place another case structure inside this case where I will wire this comparison terminal to the case structure. So if it is not equal to 0, I will get true. That means it will get into this true, into the true case. Yeah, here. So what should I do if the number is not equal to 0? I can simply divide, because if the denominator is not equal to 0, I can simply divide. I can go ahead and divide. Now, how do I place a divide operator? Simply right click, go to numeric, and place a divide operator. Okay. While we did this, we saw that there is a tunnel which has not got all its values. Why? Because there is nothing in the false case. So we should give something in the false case. What we can try, there are a couple of approaches which we will discuss. The first thing we can try is simply let it divide, but do notify the user that there seems to be some problem with your denominator, right? So I will simply let it go, let it wire. Is it done till this point, ma'am?
Yes, sir.
Okay, great. Now we have to indicate the user that there is something wrong with the operator. So how do we do that? We come to the front panel, right click, go to silver, string, and string indicator. So right click on the front panel, go to silver, string, and string indicator. I place this on the screen, name it error. Okay. Bring this indicator inside my false case. okay, and create a constant for the string indicator and say divide by 0 error. Is it done till this point, everyone? I take that as yes. Yes, somebody unmuted. Sarah, sir, you facing any trouble?
No, sir. No, sir.
Okay. No problem. So if anyone has a question, please unmute now and ask.
Sir, in the outer case structure, on the upper boundary, there are 4 cases: add, subtract, multiply, and divide. But in my case, there are all 4 cases are of add only.
All 4 cases are of add. Okay. You can simply come here and you can rename these as well. You can rename these, simply double click and rename, or first of all figure out whether in your enum, this is your enum, do you have 4 different cases in your enum, or all enums are add?
All 4 are different.
All 4 are different. Now in the case structure, for some reason you have got the same ones. Yeah.
Yes, sir.
So if you have not made your logic, okay, then I would say you can delete 3 cases. You can right click this and you can say delete this case. Do this 3 times so that your cases are deleted. 3 add cases are deleted and only 1 add case is left. Once that is done, right click and say add case for every value. Where is that? Let me just check. And I click and say, okay, I've already added for each of these operations, but if it is not added, then there will be an option showing up saying add value for each of the add case for each of the values. I can show that again. So place a case structure, okay, connect it to the operator, connect the operator to the case selector terminal. As soon as you do that, you will find 2 different cases here, add and subtract. I want to add case for every value, so I will right click. So it gives me an option saying add case for every value. Okay. And if I do that, I find all 4. Shweta ma'am, which step? I see a message from you saying, can you repeat this step again? Sorry, I missed your message last time. But which step you're mentioning? Divide by 0 error. Okay. You mean the pink portion of? Did anybody unmute? Anybody has a question? Okay. Shweta ma'am, is it this portion of the code or a complete internal case again? Okay, only this portion of the code. Yeah, I can do that again for you. I'm deleting it. Okay. Now I want to indicate the error to the user. I go to the front panel, right click on the front panel, go to silver, go to string and choose string indicator. Okay. Please remember to do this on the front panel. All controls and indicators are created on the front panel. Yeah. So I will name it as error. Okay. Now bring this error inside this internal false case. Okay. Once it is done, you can simply right click this terminal and create a constant. In the constant, you can mention divide by 0 or divide by 0 error. Simply just write that. So this indicator will display whatever you mention in this constant right now. Okay. Great. Any questions, anyone? Please ask now. Otherwise, I'll move to the next step. Okay, we need to do one more thing here. Is if I run this, it will run only once. I want to make it run continuously, so I have to put this inside a loop. So what I will do is I will go to programming, structures, while loop, place a large while loop around this. And in the stop terminal, I will create a control for the user to stop the program. And I will bring this stop to the bottom for user to stop this. Is that okay, everyone? I will run this program. We can see it is running. Let's change the operator. Let's say I do subtraction. It gives me -2.556. And let's say I multiply, it gives me 20.664. If I divide, I get 0.574. Let's test out our divide by 0 condition. Let me take it down till 0. Okay, so it shows infinity at the result and shows that there's an error of divide by 0. Okay. If everyone is done till this point, then I'm going to add a few more things here. Can we do one thing that if we find this divide by 0 error, can we make a program in a way that this result is not shown to the users? Right? Because this result is not shown, or we can just hide this indicator itself. We can just hide this indicator itself. Now, the way we hide indicators in Labview is through the properties of these indicators. Yeah. So I have this result property, this result indicator on the block diagram. I will right click this and create a property node. Okay. Right click, create property, and there is a visible property for this indicator. I will place the visible property. Okay. Before that, there is another issue with the program right now. The issue is I have placed divide by 0 error in this error terminal. Let's say even if I correct that error, it will continue to display this on the screen. Okay. So for a moment, I'm putting this visible part on hold because I uncovered another issue with the program. So let us see that. Now let's say I have, okay, you can still see my value is 234, but it still shows divide by 0 here. Can anybody tell me why?
Actually, once the false case is run, it's not getting updated after that.
Yes, the string indicator is not getting updated once it has entered the value, right? So how do we change that? We will bring this indicator, the error indicator, outside our loop, so that for every case, for every operator, there is some value going to this error. Okay, so when there is an actual error, which is this case, a divide by 0 error should go. In all other cases, an empty string should go to the error. Okay, how do we create an empty string? Just select this, press Ctrl C on your keyboard and press Ctrl V. Okay, you will get this string. Bring it outside the loop. Highlight the text and press backspace, so you get an empty string constant. Okay, place it in all other cases. The string should be given to all other cases. I will again Ctrl C, Ctrl V, get another copy of it, and I place it in all my cases. Everyone with me till this point? Everyone with me, or is anyone facing trouble? Now if we test it out.
Sir?
Yes.
Sir, if we do a use default if unwired, then won't it give a blank string or any other?
It will. It will. So let's say what Raghav is asking right now is, let's say I delete this statement here. Okay, I have deleted this. Now this string says, this tunnel says that nothing is wired to me in this case, so it is giving an error. So I can right click this and say use default if unwired. Yeah, what is the default for string? It should be an empty string. Let's try that out. Okay, so what we'll do is we'll remain in divide case, make it 0, and go back. Yeah, so a shortcut which Raghav just pointed out was, I don't want to place these strings in each of my cases. I simply want to let it use a default value. So I can right click this tunnel and say use default if unwired. Now, what is a default value for a numeric number? For a numeric indicator or a control, what's the default value?
It's 0.
Yes, it's a default value is 0 for floating point, integers, unsigned numbers. For strings, it is empty string, a default value. Yeah, both the options are perfectly fine. Okay, I hope all of you are with me till this point. Please confirm on the chat window. Then I'll move to the next step. We have to quickly get to a Talking Tom application also. So please confirm on the chat window whether this is okay or not. You've reached till this point or not. Great. Couple of people responded, so I hope all of you are with us. Now, the next step we'll do is, as soon as we find a divide by 0 error, we will hide this indicator. Okay, we will hide this indicator. How do we do that? Come to this result on your block diagram, right click this and say create property node and visible. Okay, now what is a property node? Property node is a programmatical way of accessing properties of your front panel and block diagram items. Okay, programmatically I can access their properties and change their properties, right? Right now you can see this visible property node has an arrow on the right hand side. That is, it is giving me result. It is not taking an input from me. But what I want to do is I want to control its visibility. So the arrow should be on the left hand side. What do? We can simply right click this and say change all to right. That means now I can write the property to this. Okay, so I will now finish till this point. Then I have another concept to deliver. Okay, just look at the screen now, everyone. If you're trying to make, that's fine. Hold on for a couple of seconds and see it on the screen. I cannot Control C and Control V this property. If I do Control C and Control V, the reference of the property is lost. This property was attached to this result, but when I copy paste it, its attachment to this result is lost. Okay, so for property nodes, we will never do Control C, Control V, but there is another shortcut which we will follow. Another shortcut is just select this item, press Control, go on to this property node, click and drag. Click and drag while pressing Control. Click and drag. Okay. I'll need multiple copies of it because in various cases, I want to control the visibility of this indicator. So first of all, I'll go into my error case, which is divide by 0 scenario. In this case, as soon as I go, I want to make it invisible. So I will wire a false constant to the result. Yeah. In all other cases, I should make this property true, because in all other cases I should be able to see my indicators. Yeah. So I'll keep positioning this in all other cases and keep making it true. I've pressed Control and dragged. True. Multiply. I'll place this and make it true. Let's test this out. Okay, I will run it. I will keep changing this number, bring it down to. Am I audible?
Yes, sir.
Okay, my electricity had just gone, so I was just checking if you can still hear me. Okay. Okay, now I will bring it down to 0. You can see as soon as I make it 0, this result vanishes and gives me an error, divide by 0. Yeah, I will increase this. I can get back my result and error also vanishes. I'll just be back in 10 seconds. Just give me 10 seconds. I am back. So is everyone with me till this point? You've been able to make this?
Sir, I'm not able to drag result
Drag
in property node.
this one, the property node, right?
Yes, sir. Yes, sir.
Okay, so do it with me. Let's say you have one property node. Just first of all select this. Okay, done. Then press Control.
Yes.
Press Control on your keyboard. Click this and then drag your mouse while clicking. Were you able to do it?
Done, sir.
Done?
Yes, sir.
Okay.
Done.
Now, in all other cases, we have to make it true except for the divide by 0 case. Yeah, only in divide by 0 error condition we have to make it false. In all other cases, we will make it true. Yeah. It's interesting or not? The way you can simply control the GUI of your software, simply you can add logic to your program. Right? Okay.
So
Please tell how do we get that visibility node?
Okay, this node. Okay, right click the result. Okay, this is my result, right? This is my result. Right click this, create property node and go to visible. Okay, as soon as you do that, you will be able to create a property. Now, right now this property is in the form where I can read from this, but I want to write to it. I can right click this and say change all to write. Okay, there was someone else who had a question. Could you?
yes, sir.
Yes.
Sir, why it is that if we are giving a visible property, we have to define for everyone. For a false case divide, I defined a visible property, and the other cases I didn't define. So it's not getting updated over there. And even I tried to take it out of the case structure and do like the your result and the error thing. But still the same thing was happening. Like once the result is disappeared, it's not reappearing until unless I give separately for each and every case. Why it's happening like that?
Okay, let's understand that, Raghav. Let's say what you're saying is I have made the visibility false here, right? And I don't define it anywhere else. Is
Yes,
that your
sir.
question? Let's
Yes,
say
sir.
I make this false I remove this true in all other cases.
Yes, sir.
Okay. Now, why do I not get it visible again?
Yes, sir.
Is the question, right?
Yes,
So now, Raghav, once we have in the divided by zero case, once we have written false to this, that means I have changed the property of this control, of this indicator. I've changed the visible property of this indicator. I've made it invisible in one of the cases. Until and unless I make it visible again, until and unless I change the property of this indicator again to make it visible, I will not see it on the screen. Do you agree with that statement?
Agree, sir. Yes.
Agree, right? Now you might say
property, okay.
it's
a property, it's a characteristics. Like it's changed, so it has to be changed again.
Yes, it has to be reverted back for you to be able to bring it to the original condition. Right? Once a property is written, it is written. So let's say I've written false to it, it will remain false till the time you make it true again. Right?
Agreed.
Now there is another scenario. Okay, let's say I make a copy of this. Okay, come in the true case and just make it visible here. So what I'm saying is, if I have a divide by zero error, I will make it false, it will disappear. And if I don't have a divide by zero case, it will make it visible again. Yeah. So what will happen now? What can be a condition in which I will not see the result even if there is no error?
Multiply, subtract, add.
Yes. So what can happen is, let's say I'm running the program. I don't have an error right now. I have an error now. This has vanished. Okay. Okay. And if I move to a different case now, I will not see the result because the property has not been written again. The property to make it visible has not been written again. When will it be written? When I go to divide and make it non-zero, only then the property will be written, which is not the right way of programming. What we wanted is, if there is any case where there is no error, then this result should appear. So the best way to do that is to add this property node to all the cases. Yeah, to all the cases and make it true in all the cases. I think I've missed the yeah, great. So I hope everyone is with me. Can we move to the next section of that and the audio analysis application which we have been talking about since yesterday?
Yes, sir.
Okay, great. Thank you for confirmation. Let's move on. We will now what we will do is we discussed about Arduino yesterday, right? We discussed about Arduino. We interfaced till this point, right? Now let's say I want to do you remember what was the ADC resolution of the Arduino? Does anybody remember? Do you all remember there are 3 R's of a data acquisition? What are the 3 R's of data acquisition?
Resolution, rate, and
Range.
Range, yes.
Yeah, resolution, rate, and range. Yeah. So what was the resolution of Arduino's ADCs?
10 bits.
10 bits. What was the rate at which I can read from Arduino's ADCs? Around 9 to 10 kilohertz, right? Kilosamples per second. And what's the range of Arduino's ADCs? 0 to 5 volts.
0 to 5 volts.
0 to 5 volts, yeah. Now, in an industrial scenario, let's say we are working on a process plant, or we are working on testing our next satellite which will go in space, will our voltage levels ever be only 5 volts? Satellites work on 42 volt bus and 70 volt bus, right? So 5 volt is definitely not enough for them. Now, our signals which are there on satellite runs in Gbps. The digital signals go in the Gbps rate. Their analog signals, their communication signals goes in gigahertz range. So would 10 kilosamples ever be enough for those applications? Not really. Yeah. And the resolution also, a lot of cases we need to go as high as 24 to 28 bit resolution. So there are professional DAC devices available in the market. I'll show you a quick comparison between one of the Arduino device and one of the early industrial DAC device from NI, which is like the first or the second product cost-wise. So the resolution of the ADC of the Arduino is usually 10-bit. Typically, NI would offer in its basic DAC device somewhere between 12 to 24 bits of resolution. Cost would be, Arduino would be 1 to 2,000 rupees if you buy the Made in Italy version. If you buy the Made in India version, it is available for 200 to 300 rupees as well. Now, the other thing is the NI DAC devices typically would be, starting range would be around 10 to 11,000 rupees. A DAC device would be, starting range would be around 10,000 rupees. There is usually no overvoltage protection in Arduino, whereas there is a good overvoltage protection built on an industrial DAC device. What do I mean by overvoltage protection?
More voltage because of few fluctuations that might happen. Like Arduino, the range is 0 to 5 volts. So due to fluctuations, sometimes it may happen that the input is more than 5 volts. So that would like damage my Arduino. But in the other NI's case, it won't. It has a protective circuit over there.
Yes, you're right. So basically, in an Arduino, if you give a higher voltage by mistake, or if the signal came with slightly higher variations, it may spoil your device. Whereas in industrial DAC devices, typically this protection is taken care of. It has an inbuilt circuitry to protect you against this higher voltages or variations. Now, sampling rate of Arduino is less than 10 kilosamples per second, whereas industrial DAC devices will have typically 100 kilosamples per second. NI's DAC devices can go as high as 6.4 gigasamples per second in real time. Yeah. Streaming to host, typically Arduino communicates over serial communication, so you may not get deterministically all the samples every time. Whereas on a usual DAC device, an industrial DAC device, be it from NI or be it from any other company, it typically have a direct memory access implemented, DMA implemented, which allows you to stream all the samples without losing even a single sample to your computer. Yeah. Signal conditioning, like Arduino can just measure voltage, whereas industrial DAC devices typically have various sorts of signal conditioning, which Raghu mentioned about yesterday. Right? Raghu mentioned about amplification, filtering, excitation, etc., which is available in industrial DAC devices. Okay, so let's look at one of the devices from NI. This is called MyDAC. It's a student device. It has around 16 bits of resolution, around 6 bits more than your Arduino device. It has a sampling rate of around 200 kilosamples per second, which is 20 times your Arduino. It will have input ranges of plus minus 10 volt, 2 volt, and DC coupled. Now, what do I mean by input range of plus minus 2 volt and plus minus 10 volt? What we have basically done is, yeah, somebody wanted to answer.
So basically, it has an input range of 20 volts or 4 volts.
Yes, but why have we given two ranges? Because 2 volt is a subset of 10 volt, right? If I can measure 10 volt, then I can also measure 2 volt. But why have we given two different ranges? So let's say the resolution on this ADC is 16 bits. Okay, and let's say its full range of that ADC is plus minus 10 volts. Let's say the ADC's input range itself is plus minus 10 volts. And if I pass on plus minus 2 volt signal to it, if I pass on plus minus 2 volt signal to it, what will happen? I will unnecessarily waste the ADC's resolution, which is unused, beyond plus 2 volts and below minus 2 volts. That means my signal I know is between plus minus 2 volts, but my ADC still is capturing between plus minus 10 volts and effectively wasting a resolution of 16 volts out of 20 volts. Does that make sense?
Yes, sir.
Yeah.
So yesterday, Raghu sir also told us that we will not get enough proper signal capturing if the if the signal is of low voltage and the range is quite high, just like this.
Yes, exactly. He mentioned about it yesterday, and
Yes,
basically what is happening is then if I measure plus minus 2 volt with plus minus 10 volt range, then I'm effectively losing 2.5 bits from this. How do I lose 2.5 bits from this? Basically, I am using 1/5 range of the total range, and 1/5 range means 1/5 of the range means if I use half the range, I'll get 1 bit less, right? Okay. Anyways, let's not get into the calculation of that, but we will get certainly much lesser bits than this if we use a lower range signal. If we use a lower range signal over the higher range of ADC. So that is where DAC devices typically give you multiple ranges. Yeah. It also has an analog output which you can use to generate signals, generate waveforms out of your DAC device. It also has an update rate of 200 kilosamples per second for analog output. That means you can generate a waveform of few kilohertz using the DAC device. There are also digital input and outputs. There are 8 digital input outputs. There is one high-speed DIO. The high-speed DIO can go in the range of a couple of megahertz. And there is again then there is again the 3.5 bit DMM on your DAC device. So you can also use it as a digital multimeter to measure voltages and currents, etc. There's also an audio port where you can connect your normal earphones and microphones to read audio signal and generate audio waveforms out of the DAC device. Right? So what we will do is, ideally, if it was a face-to-face workshop, we would have given you this device to work with. We don't have it today on the remote workshop, so let's simulate this device. How do we simulate this device? Go to NI Max on the start window. Just type NI Max. All of you with me? Now, once the Max is opened, Measurement and Automation Explorer is open, we can go to Devices and Interfaces, which shows up all the devices which we have to control. I already have that simulated, so I'll just delete that for the ease of understanding. Is everyone with me till this point?
So once it's open, then after that, what we have to do?
We have to go to Devices and Interfaces. Just open Devices and Interfaces.
Sir, please give us a minute, sir. It's just open.
It's loading. I know it. For the first time, it will take some time to map all your resources of the system.
Yes, sir. Now it's up and running.
Okay. I hope it's running on everyone's system right now. I can simply go to Devices and Interfaces, right-click this, Create New. As soon as I click Create New, I get this panel, this pop-up box. In this, I can select a simulated NI.MX device or a modular instrument. Basically, you can simulate a lot of NI instruments to work with. So we will simulate, we'll click on this and click finish. It will give us an option now to choose the DAC device which we want to simulate. Yeah. So we will simulate my DAC. You simply type my DAC, and my DAC will be simulated. That in everybody's system? Is everyone able to simulate?
Sir, it shows no device found.
Okay. Your installation seems to have some problem while installing.
Oh, sir, got it, sir. It was case sensitive actually, so I didn't get that.
Okay.
Okay. Now
others are able to get it?
Yes, sir, it is loading. Yeah, got it, sir.
Okay. I want to hear from everyone because for the next 30 minutes we'll be using this device. I want to hear from everyone if it is done on everybody's system.
Sir, can I please repeat once again?
Sure, sir. Why not? So I will delete it first so that we don't have any confusion. This window is open for everyone? NIMAX?
Sir, I wanted to ask that we have to install the file that you have sent named DAC-MX18 drivers, or without that also we can?
No, you would need to install that. If you had, I had given that as an optional device, I think. If you have not installed that, then you will not be able to simulate a device. But you can follow the procedure which we follow now. You can just learn through what I teach right now.
So I can do this on devices and interface things you are teaching.
No, you will not be able to do that, sir. Without installing, you will not be able to create that. For the next 20 minutes, whatever I teach, you will not be able to practice at your end. But you can just look at what I'm doing right now. Remember that for me.
Thank you.
So how many of you are with me till this point?
I am, sir.
Okay. Now I will
also.
Great. So I was just repeating for one of our participants who mentioned to repeat, who requested to repeat. So I'm right-clicking devices and interfaces and creating new. Under new, I can have simulated DAC device or modular instrument. I click on that and click finish.
Instead of right-clicking and clicking on create new, both are similar.
There's an option of create new at the top also. Yes,
Yes,
both
sir,
of them are
actually,
similar.
I did that one, so.
Yeah, you can use any one of those, and here you can type my DAC. Okay, you will get an my DAC device. If you have installed DAC-MX drivers, then you will find this DAC device here simulated. Yeah, all the devices which are in yellow color will be simulated. Devices which are connected actually to your system will show up in green. Okay, so the yellow ones are simulated. I also don't have a DAC device. I'm also working from home, so I've also simulated this for this discussion.
Sure.
Now going on to.
Sorry. If we connect the Arduino, means does it show the green color, sir?
Arduino is not an NI device, so it will not show up with the color. Arduino will show up as a COM port inside Max.
Okay, sir.
All the when I say green, yellow, this coloring will be for all NI devices. Yeah.
Yeah.
Now this is one-stop shop for all your hardware which is connected to your system. You can control all your devices, or rather interface all your devices through this single window. Okay? Whether they are connected over a remote system. When I say remote system, they are connected over a network, or whether they are connected directly to your computer. If they are connected directly to your computer, all the devices will show under devices and interfaces. Okay. So let us very quickly interface with this device in Labview. So what we will do is we will read a waveform from this device in Labview and show it over the screen. Okay. So I hope everyone is able to simulate the device. I will go to Labview, create a new VI, okay, and press Control T. I'll go to the block diagram, right click, then go to measurement IO. All the NI devices, the drivers of all NI hardware devices will show up under measurement and IO. Okay. One of us had asked a question 2 days back, which I could not answer, about what's the difference between Simulink and Labview. It seems to be very similar. Yeah, that was the question. I want to take an attempt at it to answer that. Now, Simulink is a very good tool for simulation. Okay. It is designed for simulation. Whereas Labview is not a simulation tool. Labview is a test and measurement tool. When I say test and measurement tool, you can integrate quickly a lot of hardware with Labview and build your test application. Right? When I say a lot of hardware, NI makes more than 20,000 devices, ranging from data acquisition devices to oscilloscopes to signal generators to RF analyzers to RF generators to vector network analyzers to various devices and FPGA based devices as well. So we have 20,000 NI instruments, and there are more than 30,000 non-NI instruments which work with Labview. So what Labview allows you is, Labview allows you to quickly interface, prototype your system or prototype your test system very, very quickly and help you deploy it into the industrial conditions. Okay. So what we are learning today is a simple interface with a DAC device. If I had installed all the drivers, all NI devices, drivers will show up in this window under measurement IO. Right now, I'll just go to NI DAC MX and choose DAC Assistant. Okay.
Actually, means before this starting this course, the day before that one, I was just going through that sample video, sir, as it is on the website.
Okay.
There they have used this DAC assistant, and there they said that go to video 2 for analyzing this data. But I just completed one video, sir. It was very interesting, sir. Means I had just gathered the data according to that video, 5-minute video.
Great, no problem. We'll analyze it today as well. We'll analyze the signal today. Okay. So what we will do is I'll just show you once again for people who might not have followed as to how I brought this DAC assistant. So I'll close it. If you're okay, my DAC assistant is open right now. I will just delete it and show it again. You right click on the block diagram, go to measurement IO and choose NI DAC MX DAC Assistant. All of you with me?
Yes, sir.
Okay. Now, under this, there are two options. You might get a window here for a licensing information. If it asks you for a license, you can say, yes, I understand. Did anyone get a licensing window? A window to approve licensing or something? Yeah?
Yes, sir.
What options does it give you?
So only one, license manager and I understand.
Yes, click on I understand and move forward. Okay. And you will get this window then, whether to acquire signal or whether to generate signal. I right now want to acquire signal, so I'll click on acquire signal. Then it gives me an option whether I want to have an analog input, counter input, digital input, or TEDS input. What is TEDS input? Anybody wants to take a guess at it? There are a lot of sensors which have an onboard EEPROM. On that EEPROM, they basically put a small file, which is basically the electronic data sheet of that sensor. So in various mission critical applications, let's say we are validating a satellite which needs to be launched into space. For that satellite, they are using a sensor to characterize, let's say, the vibrations of the satellite, whether a satellite can bear vibrations of 2G, 3G, 5G, 50G, which it will go through during the launch stage. So they cannot simply use these sensors which are not calibrated for ages. They use sensors which are calibrated very frequently. So while these sensors are calibrated, their calibrated data sheet is put onto the sensor itself. And when we connect this sensor to NI DAC devices, NI DAC device can directly read the calibration parameters into the Labview environment. Okay, there's a question on the chat window which says, can you show how you got create new option after measure IO? I'm sorry, ma'am, didn't really understand the question, but I would repeat this process for you if you want. I will delete this for now. Right click, go to measurement IO, my DAC assistant. I place it on the screen. You may get a licensing window here. Click I understand there and then choose acquire signals. Under acquire, you will find these options. I was explaining TEDS under this. Ma'am, are you with me? Whoever has posted that question. Okay. Now, analog input, we'll choose analog input. I explained the TEDS piece. Somebody asked, it's automatic. Yes, it's automatic. It will automatically pick up the data sheet from the sensor if you use TEDS option. But right now we don't have an actual device here today. So we will simply go to voltage and choose voltage. Now it had 2 channels of analog input. So I'll choose one of the channels of analog input, AI0, and I will finish. Okay. Now, once it comes to this window, this is a window where you can check all the settings of the DAC device. Okay. So first of all, you can check the connection diagram. It will automatically show you where to connect what. Okay. It is showing up the connection diagram. Yeah. Come back to the Express task. So connection diagram was available in this tab. Come back to the Express task. I can set the voltage range. Remember, plus minus 2 volts and plus minus 10 volts of the MyDAC. So let's say I'm using plus minus 10 volts. Now the measurement can be differential. In certain DAC cards, it can be referenced single-ended and non-referenced single-ended. That means if your sensor has AI0 positive and if your sensor has 2 wires, positive and negative wires, then you use it in differential mode. But let's say it only has one analog output and another one is ground, then you typically use it in referenced single-ended mode. For now, choose differential. And in the acquisition mode, you can choose continuous samples. I want to read it continuously. Okay. Here you can define the sampling rate of the DAC device. Let's say I want to read it at 20,000 samples per second. So I'll simply write 20,000 here. That means in every second it will acquire 20,000 samples. Okay. Now what is the samples to read? Any guesses? Any guesses?
Total number of samples.
So average continuous samples. So it will keep acquiring till the time user stops it. So what is the samples to read is basically, let's say I'm reading at 20,000 samples per second. Okay. In Labview, what if I start plotting 20,000 samples in one go? What will happen is you will find that Labview screen is hung for 1 second and after 1 second it shows data. Again, it is hung for 1 second, and then after 1 second, once it has acquired 20,000 samples, it show up on the screen. Again, it will get hanged for 1 second and then show 20,000 samples on the screen. We don't want that. We want to have user a good experience. We should continuously keep seeing data. So though we are acquiring at 20,000 samples per second, we will keep plotting, let's say, 2,000 samples in one go. That means every 100 milliseconds, 2,000 samples will be brought to LabView and will be shown on the screen. So that way your screen will continuously update, and you will not see a problem with the. You will not see a problem of hanging on LabView screen. Okay? So what this essentially says is, whenever the DAC device has 2,000 samples available, please bring it to LabView screen and display it. Okay. When will 2,000 samples be available on the DAC device? After every. So I am acquiring at a rate of 20,000 samples per second. When will 2,000 samples be ready? Will it be 1 second? Sorry?
1/10 of a second.
1/10 of a second, because it is 2,000 is 1/10 of 20,000. So within 0.1 seconds, my 2,000 samples will be ready, and every 0.1 seconds, I will see fresh data on my screen. Okay. If I make it, let's say, for the sake of understanding, if I make it 4,000, then what happens? My screen gets new sample every 20 milliseconds. Yeah. Oh, sorry, 200 milliseconds, which is 0.2 seconds. If I make it 6,000, then I will get it after every 0.3 seconds, 30 milliseconds. So what I'll do is I'll keep it 2,000 right now. Typically, it's good to keep this number 1/10 of this number. Okay. I will press OK now, and I will go ahead and program this. Now it is asking me, you have put the task into the continuous acquisition mode, but I don't see any while loop. Should I place a while loop because you're acquiring continuously? I would say yes. So it automatically creates a while loop. Okay. Now we will have, we're getting data on this terminal. Okay. So we want to present it on the screen. So what I'll do is I'll go to the front panel, right click, go to silver, choose a waveform chart. Please remember, use only waveform chart, not waveform graph. In couple of seconds, I will explain the difference.
Sir, I have a question.
Yes, sir.
Means you said for Windows, silver control is more preferable, right, sir?
Yes, sir.
Means what if we use from the modern control, sir?
Absolutely no problem, sir. The looks of a silver control is better. So your user experience or experience of the user will be better with silver controls. With the modern controls, they're slightly older generation of controls. So I can use it from there as well. Let's say I want to use waveform chart from modern. This is a modern waveform chart, and I'll show you how the silver one looks like.
Okay, means they're actually contrast, sir. The name is modern, but the graphics is of old age.
Yeah. Reason being, the earliest ones were classic, sir. The earliest ones were classic. Then the modern came, and then silver came. And we have also started launching next generation, so we have Nxg ones as well. But for this course, I would recommend you to use silver ones, which looks the best.
Yeah, it looks best, sir. Okay, sir. It was just a doubt.
Okay. No problem, sir. So you have placed a waveform chart. This is everyone is able to place a waveform chart on the screen.
Just a minute, sir.
I will repeat that for you. So come to the front panel, right click, go to silver, graph, waveform chart.
Waveform chart silver, first one, right, sir?
Yes, first one, sir.
Yes, sir. Placed it, sir.
Placed it, bring it to block, look at it on the block diagram and connect it with this data terminal.
Okay, sir.
Okay, now let me run this program. We will see a simulated waveform. So simulated waveform on a dark device is typically a sine wave with a noise signal. Okay, there will be a sine wave plus there will be some noise overriding that sine wave. So I'll run it. You can see a sine wave with some noise riding on top of the sine wave. Yeah. Is everyone getting it? We have 23 more minutes before we want to finish talking Thomas Welch, so please respond.
Yes, sir. We are getting it, sir.
Great, great. Now we have this waveform chart. What we will do next is we will filter this noise out. How do we filter this noise out?
Sir, are we getting the noise? Means, can you hear the sound?
No. When I say noise, I forgot your name. Naveen sir, is what I meant is you can see this thick band of waveform, right? The waveform is not thin, it's a thick band of waveform. So right now we're just acquiring signal. So the signal has an onboard electrical noise.
Okay.
Okay, do one thing. Right click this right click this indicator, which is this graph. Go to visible items and say graph palette. Okay, please everyone do that with me. As soon as you click on graph palette, you get a graph palette here, which basically has a zoom option. So we'll zoom this waveform and see whether there's an actual noise or not. Okay. So
okay.
Once this is visible, once this graph palette is visible, click on the zoom icon and let's say choose this one, the first one, the first zoom option, and we will zoom on a selected area of our waveform, let's say this portion. Can you see this noise?
Oh, now I can say it's a noise, sir. Yes, sir.
It's a noisy signal, right?
Yes, sir.
So we will come back and say, we'll click on zoom again, and there's an option to look at the full view of the signal. So I'll click on the full view, and this is the full view of the signal.
Yeah, got it, sir. It's a noise, sir. Yes, sir.
Now we will go back to the block diagram and remove this noise. How do we remove this noise?
I don't know, sir.
We pass it through low pass filters, right? Sorry, somebody said something else?
Sir, by filtering.
By filtering, yeah. So we'll use a low pass filter. How do we use a filter? So we will right click on the block diagram and go to express.
Sir, how did you do the full view?
In the zoom option, there is an option to choose this one. Okay. You'll have to, of course, expand your graph or expand your chart. Yeah, expand your chart to a good extent. Now, I'll just do one more thing. I missed one point. I mentioned I'll talk about the difference between the chart and the graph. So chart is something which is having the history as well. When I say history, this complete sine wave was not brought from the DAC device in one go, right? A few samples came, we plotted those, then few samples came, we plotted those, right? What if I had used a chart? Can we try that? What if we had used a graph? Can we try that? So right click on the controls panel, go to silver, graph, and place waveform graph. connect this waveform graph as well to this data. Okay, and I'll run it again. Can you see this graph only shows a piece of the data, whereas the chart is continuously updating and keeps the history as well. To make it more clear for you, so you can see the graph is showing you the instantaneous signal, whatever is being acquired from the DAC, whereas chart shows you full history of the signal.
Sir, please show the block diagram for 1 second.
Yes, you can see the block diagram.
Yes, sir. Thank you, sir.
Okay, I hope you're able to connect it this way.
Yes, I'm connecting it.
Is everyone clear with the difference in graph and chart? What's the prime difference between graph and chart?
Oh, yes, sir.
Graph shows the instantaneous signals, whatever is acquired from the DAC, whereas chart also retains the history of the signal. Like whatever came in the previous iterations or 2 iterations back, that is also available on the chart window. Yeah.
Sir, the graph is actually very fast, sir.
The graph seems to be very fast because it is only showing the instantaneous signal. So the x-axis is only for 10 milliseconds. You can see 10 milliseconds. We had chosen 2000 samples out of 20,000. So every 100 milliseconds, we had a one set of data. So it is updating every 100 milliseconds. Right? Whereas on the chart, also data is being written at 100 milliseconds, but the x-axis of the chart is much higher than 100 milliseconds. X-axis is actually more than 1 second, whereas it is only 100 millisecond here on the graph.
Okay, sir.
I'll stop it. Let's go to filtering now. So before we filter the signal, how do we figure out what should be the cutoff of our filter? How do we define the cutoff? By just looking at the signal, we can't define the cutoff, right? Can anybody, by just looking at the signal, define the cutoff of the filter? No. So we basically do a spectral analysis of this signal. So, and based on that, define the cutoff of the signal. Yeah. So we will do spectral analysis. Okay. So to do spectral analysis, what we will do is we'll right click on the block diagram, go to Express, Signal Analysis, and click on Spectral.
Just a minute, sir. Yeah.
Right click on the block diagram, go to Express,
Signal Analysis, Spectral. Okay, sir.
yeah. Keep it with the default settings onto the block diagram. Wire your signal to the spectral measurements block. Cut out
Sir,
this
actually,
one.
I have got one dialog box, sir. Configure spectral measurements.
You can leave it to default and press OK, sir.
Okay.
Now wire your signal to the spectral measurements block. Then cut off this wire which connects waveform graph and this signal. We will use this graph which we had placed earlier for viewing the spectral data. Done, everyone?
Just a minute, sir. Sir, actually show the block diagram, sir. Means we should disconnect it from this signal, data, right, sir? Waveform graph.
Yes, you can disconnect from the data and connect it to the output of the FFT RMS signal.
Yeah, connected, sir.
Okay. If there's any bad wire, you can clear bad wires by Control B. Yeah, done. Let's look at the spectral analysis of the signal. I'll just run this signal and auto scale Y and auto scale X. Now you can see that there is a wideband noise. When I say wideband noise, there is no noise of a particular frequency. There is a wideband noise. The dynamic range of the signal is only around 60 dB. Okay, but dynamic range is only around 60 dBs. Okay, whereas a dynamic range of a pure software simulation signal should be very high, 80, 90 dB, 100 dB. Right? So that means there's a wideband noise, not a noise of a particular frequency. When you work in industry, like let's say a day before yesterday, there was a satellite which is being tested in a thermo vacuum chamber at Space Application Center. I received a call saying, hey, the system seems to be performing in an erratic manner. It is showing a lot of ringing noise on the signal. So what we did is I quickly just checked them, asked them to plot a spectral graph. They plot a spectral graph and we figured out that the noise was at 50 hertz. We saw a peak of signal at 50 hertz, whereas our signal was of few hertz, let's say 10 hertz or 5 hertz. But we saw another peak at 50 hertz. What does that infer? That infers basically it is picking up the noise from your power lines.
Yes.
You know, your power lines.
Sir?
Yes.
Vinit, sir?
Yes, sir, I can speak, sir.
Can I ask one question?
Yes, absolutely, sir. Please feel free.
Actually, you are saying that we are looking for spectral components. Yes?
Yes, sir.
By means of this. So then why this excision time?
I mean, okay. So I had used the same graph which had showed the data of the waveform earlier. I can always rename it as frequency. The x-axis is actually frequency.
So it is not coming. Okay, sorry. I thought it is coming automatically in the graph. That's why I asked you.
No, it is. You have to select it, sir. So you can name it frequency. Now you can clearly see that we had acquired 20,000 samples, and it is showing you the spectral analysis up to 10 kilohertz frequency.
Okay, sir. That was the question. Okay, sorry.
Nyquist. No. I mean, I'm sorry. Actually, I did not mention it here. So thank you for bringing it up, sir. Okay?
Yes.
Now, so what I was saying is, let's say we see a 50 hertz noise, then we clearly see that it is picking up the noise from the 50 hertz lines in the environment, which is our power lines, right? So we could quickly put a 20-25 hertz software filter. In our case, let's zoom in this data a little, right? How do we zoom in? I will change the x-axis. Let's say I make it 200 hertz. Okay, so I can clearly see my data is somewhere in the range of up to 20 hertz. Can I put a filter of, let's say, 30 hertz and cut off all the noise components beyond that? My waveform is actually in this first lobe, and rest everything else is a wideband noise. So what I'll do is I will basically put a filter of 30 hertz to cut off this wideband noise. Let's do that. Now right click on the block diagram, go to Express, Signal Analysis, and put a filter. Okay, keep it a low pass filter, cut off frequency of, let's say, 30 hertz. I will leave all of the settings to default. I'm using a Butterworth IR filter. I will say OK. All of you with me? I had right click, went to Express, Signal Analysis, Filter.
Sir, why it is named as express, sir? It means it is nothing related with the signals.
Nothing related to signals. I will explain that in a couple of minutes. Why it is named express. Actually, when I'll make talking Tom, then I'll explain that. Yeah.
Okay, sir.
Okay. So now what we will do is everyone is able to put this filter with 30 hertz cutoff frequency.
What model it will use?
Sorry.
I think
Okay. Okay. Now what we will do is we will cut off the wire from here. Okay. Pass this data directly to this signal input of the filter. Connect the output of the filtered data with the waveform chart as well as the spectral graph.
Sir, please just repeat this wiring, sir. Means.
Okay. So if you look, I'll delete all the wiring for now. Our data which is we are getting from the DAC device should go to filter first of all. Am I right?
Yes, sir.
Because we are passing it through a filter now. Okay. I'll bring it closer. You can double click on the wire. Right click, clean up wire. So wire will get cleaned up. Okay. The filtered signal is what I want to show it on my chart. That means on the waveform chart which I had placed, this one, where I had this waveform, I want to show the filtered data here. So filtered data directly.
Can you just press Ctrl and U and let's see how it gets arranged itself, sir.
Okay.
Ctrl U.
It will be different for every different ones because it depends on how you place your components in ECB.
Okay, sir.
So I have the spectral measurements block now. So data goes to filter, output of filter goes to waveform chart, and the same filtered data is passed through spectral measurements for you to see the spectral components of your signal. Okay. The dynamic range of your signal, that means this 20 dB minus this noise floor, should improve. Okay. And this waveform should also have a thinner band.
Sir, actually now I am little bit confused. Means I did not connect filter to anything. Means just a minute.
Okay. So the output of the signal goes to filter. Sir, you agree with that?
Yes, sir.
Now the signal goes to filter, and the filtered signal goes to the chart for display. Okay. I want to see the filtered data on the chart.
Yes,
and the filtered data also goes to spectral measurements block for spectral analysis.
Yes, sir. Data is connected to signal and filtered signal connected to waveform chart.
And also connected to spectral measurements block.
Sir?
Yes, Raghav.
Sir, how do we add a waveform chart and graph? I just couldn't find it where it is. Can you just tell me again?
Sure. So on the front panel, okay, right click your front panel, go to silver, graph, and waveform chart and graph.
Got it.
Sir, please open the block diagram and just give me a minute, sir.
Sure.
Means just enlarge the block diagram.
Okay. Is that fine now, sir?
Yes, sir. Just give me a minute, sir.
Sir,
Yes, sir.
by spectral analysis, how did we come to the cutoff value of 30 hertz? Can you please tell as well?
Okay. Okay. I'll explain that. This question is asked by whom?
Deepak Gupta.
Deepak sir. Okay. Deepak sir, basically, what does the spectral analysis do? Basically, a time domain signal is converted into frequency domain through FFTs. Yeah. Once a time domain signal is converted to frequency domain signal, it will show up all the frequency components of the signal, right? So the signal which we had seen earlier before filtering, that was a sine wave, but over the sine wave, there was some noise which was added on top of it. Yeah, there was some high frequency noise riding on top of the sine wave. Is it clear till this point, sir?
Yes, sir, it is clear.
Okay. Now, once we do the spectral analysis of it, we will understand our frequency component of our the signal of interest and various other frequency components of noise signals. Okay. Now, let's say if it was a particular noise signal, let's say 50 hertz or 100 hertz or a 200 hertz noise signal, then that would have shown up as a peak on the spectral curve. Okay, I will show you that how it will show up. I'll just give me a couple of seconds. I'll show you that as well. But now when I did the spectral analysis, what I saw was there was no specific peak of a signal, but the total noise floor of the signal. The noise floor of the signal was itself sitting at minus 40 dB on the spectral curve. While the signal is at such a high noise floor, the simulated signal should be in minus 90, minus 100 dB noise floor range, right? Whereas it is showing up minus 40, that means there is a wideband noise. So I chose a frequency to which my signal of interest is present. So my frequency of this sine wave, which is up on the screen, is not more than 3 to 5 hertz. Whatever the sine wave you can see on the screen, the frequency of the sine wave is not more than 3 to 5 hertz. Yeah. So what we did is we took the spectral graph, saw where actually my prime signal is, and from where onwards the noise is starting. When I did that, I found out the noise was sitting at somewhere greater than 20 hertz. I'll show you that. So what I'll do is I will remove this filter block and put a diagram disable structure around this. You need not do it with me. I'm just doing it to explain the concept of defining the cutoff. So I will run this. Now you can see the noise floor signal is sitting at minus 40, 50. So I reduce the frequency range to zoom in this area. Right? I will first of all have to disable auto scaling of my x-axis. So I right click this graph, disable auto scaling, go to let's say 200 hertz. That means I have zoomed in into my signal. So you can see my primary lobe is somewhere in the range of 20 hertz. Okay? Post which is what I can see a wideband, post which is I can see there is no signal power for my actual signal, for my primary signal of interest, but there is some noise floor, right, at minus 40, 50 hertz. Noise floor should have been at minus 80 or minus 90 dB, right, or a very low noise power or very low power of signal. But I can see it at a minus 40, 50 dB starting from 30 hertz itself. So I've decided a cutoff here at 30 hertz. Am I making sense, Deepak sir?
Yes, sir. Okay.
Okay. So I will place the filter back. Okay. We will see the signal now. How it looks like. It will be a much cleaner signal. Okay. And you can say noise floor has moved back to minus 90, minus 100 dB. Let me auto scale the x-axis. You can see it's going down minus 100, minus 20 dB. The noise floor of, in an actual system, we can't go beyond the noise floor of minus 174 dB. On a simulated signal, you can. because minus 174 dB is a thermal noise floor. Somewhere in that range, my numbers might be few dBs here and there, but somewhere around minus 170, minus 174 dB is the thermal noise floor. So a simulated signal should actually go to that noise floor or better than that. Right now it is touching minus 220 dB, which is theoretically not possible for an actual signal, but for a simulated signal it is possible. You will also see that my signal on the waveform is much cleaner now. I don't see a wideband noise overriding my signal like earlier time. Yeah, is that clear to everyone? Is that clear to everyone?
Yes, sir.
So we can see our waveform, which is much cleaner now. Okay. What I'll quickly do is, instead of this dark block, I'll take 2 more minutes to explain this concept of filtering even better. I will use a simulated signal instead of a dark block. I've got the signal from dark, but let's simulate another wave, another signal. So let's get to express input and simulate signal. Okay, express input and simulate signal to get a simulated sine wave of, let's say I get this of 10 Hertz frequency and click on simulate acquisition timing and press OK. Press Control and drag it down. You need not do this with me. I'm just showing it to you. You need not do this with me. Just let me show you this. Now I have one signal of 10 Hertz. Let me add another signal of 1000 Hertz. Okay, for 1000 Hertz, I need to have the samples per second as 100,000. Okay, for this one also, I need to make 100,000 samples. Otherwise, it will show an error. Okay, now I have one signal of 10 Hertz, another of 1000 Hertz. I will mix these two signals. Okay. Of course, I will reduce the power of the higher frequency signal. Otherwise, it will show up as a very different signal. I've reduced the power of the high frequency signal. Now I'm passing this signal to the directly to spectral measurements block. I'll remove filter in between, pass it directly to spectral measurements and to the waveform chart. What we should see on the screen is there should be 2 peaks in the waveform graph, which is spectral, doing the spectral analysis. Let me zoom in these signals and show you. So visible items graph palette. Auto scale axis. Can you see 2 peaks? One at 1000 Hertz, one at maybe 10 Hertz. I'll show you the signal. Can you see a signal with a lot of noise riding on top of it? Shweta ma'am, I forgot to answer your question. It is connected to FFT, not phase. Okay. Is it clear? You can see two peaks and the signal riding on top of it. Now, if I have to filter it, what frequency should I choose? What should be the cutoff frequency of my filter now? If I only want to have this signal. Any answers? What should be the cutoff frequency of my filter?
30 Hertz.
Sorry?
30 Hertz. We just zoomed from that I guess.
So, but my noise floor is at very minimal value, sir, minus 325 dB, right? Theoretically not possible. Practically not possible. But noise floor is very low. So I want to remove this signal. So I can use any frequency lower than this signal, right? If I set my cutoff frequency as, let's say, 600 hertz, then I will still be able to cut this off. Deepak sir?
Yes, sir.
Yeah, I don't want to remove this noise floor because this is very, very minimal. Earlier it was at minus 40 dB. So it was a problem for me. But right now this signal is not a problem. But this signal is definitely a problem. So any cutoff frequency of a low pass filter below this peak would help me remove this signal. Okay, let's try that. That will be the last thing and then we'll break for lunch. So I will add a filter now. Go to Express, Signal Analysis, Filter. I will put a filter of, let's say, 500 hertz frequency, low pass. Okay. And you can see the power of this component has come down from minus 25 to minus 50 dB. If I zoom it in this range. Okay. So if I further reduce the frequency or increase the order of the filter, the power of the noise component should further come down. Yeah. So if I make it 100, the filter will roll over better, and the power of the signal should further go down. You can now see the signal has gone down to minus 75 dB with respect to 0 dB of my actual signal. Deepak, so you can see the power of the signal is continuously going down as I change the cutoff of the filter. Yes. Okay, with that, I think we can break for lunch. Let's meet at 2:30 p.m. Is that okay for everyone?
Yes, sir.
Okay. 2:30 or 2:45?
2:30 is okay, sir. Means it's okay, sir. 1 hour is more than enough. Thank you, sir.
Thank you.
Thank you, Vineet, for this wonderful session. I think afternoon we'll have machine vision, right?
We are yet to finish Talking Tom piece, sir. So I want to finish Talking Tom and then get to machine vision.
Okay. Yes. So these are signal processing applications you have taught.
Yes, sir. Filtering, signal processing. Now we will work on play around with the waveforms as to how we can change the frequency of the waveforms to create a different signal.
Sir, after completing this means it will be in action, right, sir? Means Talking Tom actually it replicates what we say. Means it will do
Absolutely,
that.
sir. Absolutely, sir.
Sure, sir. Okay.
Just one thing, can we make the second session today a slightly longer one? Can we run it from 2:30 to maybe 4:45 instead of 4:30?
Yes, sir. You can take it till 5, sir. No problem.
Parikshit, sir,
Means my point of view. Please ask the rest of us.
I think all the participants are enjoying. So as long as I think we can finish around 4:30, 4:45. I think it will be over. Little bit you can go little fast maybe for the machine vision thing.
Sure, sir. Okay.
Thank you so much. All the participants, let us meet at 2:30 p.m. Thank you, Vineet. hectic
Thank you,
for
sir.
you, I know.
No problem, sir. Let's meet at 2:30. Thank you.
Yes. Thank you.